Is there a copy of you watching this video? A person who is not you, but also lives on a planet called Earth, in a solar system with 7 other planets. The life of this person has been identical to yours in every aspect, but perhaps he now decides to close this video without finishing it, while you keep watching. Physicists have been fascinated by the idea of parallel universes for a long time. It was first proposed in a serious way by Hugh Everett in 1957, just after his work on quantum mechanics. Dr. Max Tegmark is a Swedish-American physicist, cosmologist and professor at MIT. He is the author of Our Mathematical Universe and Life 3.0. According to Tegmark, the multiverse is not just a staple of science fiction. He argues that there are at least 4 different kinds of parallel universes lurking out there. Together, these multiverses comprise everything that exists, the entirety of space, time, matter, energy, information, and the physical laws that describe them. They are arranged such that subsequent levels can be understood to encompass and expand upon previous levels.
When we say our observable universe, or just our universe for short, we don't mean all of space. We mean this, the region of space from which light has had time to reach us during the 13.8 billion light years since our Big Bang. We humans have again and again made this mistake of thinking that everything we knew about was everything that existed, just to discover that that was just a small part of a much grander structure, right? A planet, a solar system, a galaxy. Now, the most popular theory we have, called inflation, actually predicts in the simplest versions that space goes on forever. And if that's true, then you can fit infinitely many other universe-sized regions into this, where there will also then be galaxies, if you roll the dice and things start at randomly, copies of us having all sorts of variants of this combination. This is what I call the level 1 multiverse. Even more interesting with this inflation theory, because it turns out it makes almost like a fractal space, where there are these boundaries where inflation never stops. Everything within an expanding boundary is a level 1 multiverse.
A prediction of cosmic inflation is the existence of an infinite ergodic universe, which, being infinite, must contain Hubble volumes realizing all initial conditions. Inflation predicts a multiverse where every possible history of the universe exists as an expanding Hubble volume. It would, however, be an error to say that it is the actual universe and ours is simply a tiny part of it. It is just another Hubble volume, albeit an infinite one. In the internal inflation theory, which is the variant of the cosmic inflation theory, the multiverse, or space as a whole, is stretching and will continue to do so forever. But some regions of space stop stretching and form distinct bubbles, like gas pockets in a loaf of rising bread.
And inflation is going to make all these different kinds of space. That's the level 2 multiverse. So there might be somewhere far, far away where people learn in school that actually the periodic table has only 5 kinds of atoms, or 180 kinds of atoms, and so on. Not because physics is truly different, it's still maybe ruled by string theory, but a lot of things that we thought were fundamental weren't. It's like if you were a fish and you spent your whole life in the ocean, you might think it was a law of physics that water is always a liquid. And you would learn that water has this kind of viscosity and this kind of sound speed, which is not true if you're inside of an iceberg or a steam cloud.
Many worlds interpretation is one of several mainstream interpretations of quantum mechanics. In the early 20th century, the theory of quantum mechanics revolutionized physics by explaining the atomic realm, which does not abide by the classical rules of Newtonian mechanics. One potential resolution to the paradoxes of quantum mechanics suggests that all possible outcomes of quantum events actually occur in separate realities, each with its own probabilities.
Quantum physics, the theory of the very small, we've discovered that when we look really closely at the electrons and these other elementary particles that make up us, they can be in multiple places at once. But we're made of them, so that means we should be able to be in many places at once. So this kind of branching and amplification of weirdness from the micro world, where a little atom is in two places at once, into the macro world, is what leads to this many worlds interpretation of the level 3 multiverse.
Certain observations cannot be predicted absolutely. Instead, there is a range of possible observations, each with a different probability. Although reality gradually splits into superpositions of many such realities, observers subjectively experience this splitting merely as slight randomness in the measurement outcomes. It is possible to see these as separate classical parallel worlds that exist simultaneously with our world. In this way, every quantum event creates new parallel worlds where history can continue independently from the path it took in our world. The ultimate mathematical universe hypothesis opens up the full realm of possibilities. Universes can differ, not just in location, cosmological properties, or quantum state, but also in the laws of physics. Existing outside of space and time, they are almost impossible to visualize. This level considers all universes to be equally real, which can be described by different mathematical structures. This is the cosmological theory of everything.
So let's break it down a little bit. Like if you take an object like this book, for example, if you look more closely, what you actually have here is a big blob of electrons and quarks. And what properties does an electron have? -1, 1/2, 1, and so on. And even though we physicists have given these properties nerdy names like the electric charge, the spin, the lepton number, they're just numbers. The only difference between an electron and a quark, as far as we can tell, are what those corresponding numbers are. And space itself, that all of this stuff is in, what properties does space have? 3 is a property of space. That's the largest number of fingers I can hold that are all perpendicular to each other. Again, you know, we came up with a nerdy name for this, the dimensionality of space, but it's a number.
Any conceivable parallel universe theory can be described at level 4 and subsumes all other ensembles, therefore bringing closure to the hierarchy of multiverses, and there cannot be, say, a level 5. A common feature of all 4 multiverse levels is that the simplest and arguably most elegant theory involves parallel universes by default. Tegmark argues that denying the existence of these universes, one needs to complicate the theory by adding experimentally unsupported processes and ad hoc postulates, infinite space, wave function collapse, and ontology asymmetry. If Tegmark is correct, this represents a paradigm shift in the relationship between physics and mathematics, forcing us to rewrite our textbooks. Prominent physicists are divided about whether any other universes exist outside of our own. Some of them think that the multiverse theory could at least be rendered more plausible by the existence of dark energy in our universe. However, others argue that the multiverse is a philosophical notion rather than a scientific hypothesis because it cannot be falsified. According to the best current measurements, for a universe with only matter and no dark energy, expansion would slow but never quite stop. But if dark energy is indeed uniform throughout space, then it has a significant negative pressure, and this will tend to lead to a cosmic contraction rather than an expansion. If our universe were merely one of infinitely many, there would be no way to confirm that any of the others are distinct rather than part of an infinite multiverse. In other words, no external observer could ever determine whether his universe was special in the sense that it is exempted from sharing its characteristics with other universes. So, should you believe in parallel universes? Let us know in the comments section. Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this.